Hello and welcome. Today is a very wonderful day because we are going to be entering machine learning today. We're going to be taking the first course in machine learning, which is simple linear regression. You have been plotting graph of x against y. Plot the graph of what? Y against x. You've been doing it in mathematics. Today we're going to be doing it using Python. You can also plot graph using Excel. Today we're going to do it using Python. Then if we plot it and we get the line, we should be able to use the line and predict if y is now this, what will now be x, or if x is now this, what will now be y. And that is the same way we are going to use in predicting the future price of stock or the price of houses in the USA. So we're going to be doing all this. So we'll start with a very simple example, you understand? Then after learning how you can plot basic graph, you understand? The next class will be how to use it to predict the price of something. And once you want to predict, you use what we call linear regression. We use what we call what? So our machine learning class is going to move from linear regression of single property to multi-value, you understand? Then we'll move to classification. Then we'll move to clustering. Then finally we'll move to deep learning. So with these 4 courses, we are going to finish it within this week. You'll be having a good grasp of machine learning and be getting ready for the hackathon that we're going to be taking part in. And to do this, I'm going to quickly share my screen. Please, who can hear me very well? Digital audience that can hear me very well. You can hear me very well, but so let's get started immediately. Let's get started. So all the codes we are using and all our lectures, they are already on our website, www.tclassified.com. Get to the website, click on blog. Click on blog. So the blog in this website is for all your software development training. So you can see I updated React.js and Node.js yesterday. That's what I did. So machine learning, that is what we are learning. So you click on it. So all the codes that you need to do whatever I'm doing, they're already there. Okay. So earlier I've explained what data is, what machine learning is, what data science is, why we call it data science and the rest. So today, there is no more theory talk today. Today we are going to start coding immediately. So this is the first project that we are going to be doing. Based on the area of the room, you should be able to predict the price of any room in where. So this is sample from prices of rooms in Monroe, New Jersey, USA. You understand? So if you go to Monroe, New Jersey, USA, you're going to find out that for a house, you understand, or a home with this square area, the price is this. You understand? So you're going to be able to predict, given another area, what will be the price. So that will be what we are expecting to do. But to do this and understand this very well, we are going to learn about plotting basic graph using linear regression in Python. And to do that, please simply come down to this place and see where I wrote basic example. That's what we are doing now. Basic example. So this is what we are going to be doing. To do it very well, you're going to start up your Jupyter notebook. I hope everybody has Anaconda in his system. So to start it up, just click on your search. Once you click on your search, just type Jupyter notebook. As you're typing, it should come out. So you will see where it is written, Jupyter notebook Anaconda 3. That's what we are using. Can you see it here? Jupyter notebook Anaconda 3. That's what you're using. Just click on it. Once you click on it, you're going to see something that looks like this command prompt. So once this opens, wait until it opens up in the browser. If this comes up, after some time, it's going to open up in the browser and you're going to see exactly something like this. So once you're here, tell me that you're here so that we'll start. So you see the way I said it, go to your search, type in Jupyter Notebook, click on the Jupyter Notebook. Once you click on it, this command prompt will open. Then after a while, your browser will automatically open to Jupyter. Because Jupyter Notebook, Anaconda has Jupyter already inside it. And with that, we can do this work. Yeah, Ola, you want to ask question? Let me take your question before I continue.
No, I don't think so, sir. I just joined
Okay,
I joined late.
Okay, okay.
Yes. So I think I've not. You haven't gone too far.
No, I haven't done anything much. I just went to my search, then I typed Jupiter. The P is Y. Jupiter. Then it will come out here. Click on it. Jupiter Notebook Anaconda 3.
Yes,
Once you click on it, this will open up. So this that opens up, you wait for some time. After some time, your browser will automatically open up to here. So this is where I want everybody to be in so that we can continue. Is everybody here now? Okay.
Yes,
so the whole class is here now. If you're following me, digital audience, and you're not here, wait for it. Then follow me on my YouTube channel. You see the rest of the class. So once you're here, the next thing to do is for you to go to new. Can you see new here? Can you see this new? Click beside that arrow beside the new and click on Python 3 because that's the kernel we are using. So click on it, Python 3. Click on the arrow beside new and select Python 3 as the option. Are you there? So once you do that, it will open up your Jupyter Notebook. And this is my Jupyter Notebook, opened, ready for me to start writing. Are we there? Should I continue?
Yes,
You're there, Bar. Thank you. You're there, Bar. Thank you. You're there, Bar. Thank you. So everybody is there. So the next thing we'll do is for you to give a name to your notebook. So I'm going to click here. Can you see on title 1? So click on that on title 1 and give it a name. So the name I'm giving is Linear Regression or Steino. Linear regression or Steino, all written together, no space. Then I'm going to click on rename. So that becomes the name of this project, Linear Regression or Steino. So give it your own name, but let it have linear regression on it so that you know. Because next, when we start doing clustering, you name it clustering. When we start doing classification, it becomes easy. Are we together on that?
Yes, sir.
Are you done? So the next thing is to start writing our code. You are going to see the few codes that we are going to use to plot a graph and do mathematics, predict the formula. You know the formula for a straight line. What's the formula for a straight line? Y equal to what? Mx plus what? C. Isn't it? Y is what is the dependent value, isn't it? M is the what? The slope. X is the what? Independent value, isn't it? Plus C. C is the what? Intercept. we are going to use some value now, plot it out, and bring out our interception and everything in a very simple way. Very, very simple way. So with the knowledge of that, that's what we use in doing our prediction in the next class. Okay. So to get going, let's quickly get to our website, you understand? Let's know what and what do we need to import. Which Python packages will help us to plot this graph? Which Python packages? Is that clear? Python has all these things already inside Python. Even more sophisticated than what you have in Excel. More sophisticated than what you have in what? Class, more sophisticated than what you have in what? Excel. The ones in Python are more. So what are those things? What are those packages? We are going to be importing NumPy. We are going to be importing what? NumPy. NumPy is a Python package that you can use in manipulating arrays, numerical arrays. Is that clear? Very, very important package. Somebody have already written it and kept it there. Just for you to use it, input your value and get what you want. Is that clear, class? Then another package that we're going to import is what we call Matplotlib. Matplot what? Matplotlib is a package that you can use in plotting your graph. You understand? That is what we use in plotting graph. Somebody have already written this code, kept it for you also in Python. Is that clear? Then the final thing we are going to report is what we call sklearn. sklearn is a model that can help you to predict something. You understand? Looking at the history of that very thing, it will predict the future for you. And those are the 3 packages that we have. And to put those 3 packages, I'm going to just pick them up here. Very simple. Very, very simple. Pick them up here. Go to my stuff and do what? Put them. Or you can type them out by yourself. Once you put them, class, are you listening to what I'm saying? Click on run. Click on run. If you don't click on run, it will not know that you've given this instruction. So I'll click on run. Because I've clicked on run, that's why I'm seeing the next line. So once you click on run is the same thing as saying save if you're using your VS Code. Is that clear? So it has taken care of this. It has imported this. Very, very importantly, are you listening to me? If you look at this importation, you are always seeing as. Import numpy as MP. Import matplotlib.plot at PLT. When you see as simply stands for alias. Now you import numpy. The interpreter already knows that you have numpy. You understand? But when you want to reference that numpy, instead of writing numpy in full, you just put MP. You understand? Anywhere it sees MP, those are its numpy. Class, are we clear on this? Just 5 lines of code, you are done. Just 5 lines of code, you are done. So what do we want to plot? This is what we want to plot. Are you looking at my screen? Can you see the Excel spreadsheet that I have opened? Can you see the Excel spreadsheet? This is what your X and this is your Y, isn't it? This is your X and this is your what? This is your X and this is your Y, isn't it? If you want to plot in mathematics, they will give you your X and Y value, isn't it? Or they will give you a formula that from the X, you will not get the Y, isn't it? Here, we want to plot and derive that formula. Is that clear? With that formula, that's what we use in predicting. That's what we use in starting our line. Is that clear? So this is what we are plotting. Is that clear? So how do you bring in this, what's it called? This Excel table into here. How do you bring it in? That's where you're going to use your numpy. That's what you're use that your what? Numpy that you were earlier in, because I told you that you can use numpy to manipulate numerals, isn't it? Isn't it what I said? That's why you imported numpy. So what do we do next? We simply go here, go back to this thing, then we'll put in, can you see? All X, now we are assigning in all these values. And all Y, we are assigning all these values. So I just pick them up and get back to my notepad, to my Jupyter notebook. I put. Once after putting, what do? Run, isn't it? So I've run. So what's the relationship between what I have here and what I have on this Excel? Who can tell me the relationship? It's very, very clear, isn't it? This is what we have. These are X, these are Y, isn't it? Then we'll now put this list. You know what a list is in list is a what? Is a data type, isn't it? For array, isn't it? So you are using this list, you're compacting this list to an array, numpy array, isn't it? So you're putting all these values. X is what? 1 to 10. You can see here X is what? 1 to 10, isn't it? Y is what? 2 to 22. Y is what here? 2 to 22. Can you see that? So once somebody gives you this value in Excel, you should be able to put it in your as a numpy array. Can you do that? Very, very simple. So I'll simply say X is equal to MP. MP is the numpy, isn't it? Because you imported numpy as what? MP, isn't it? So numpy array, then in brackets, you put the list. And the list you get from what you have been given. Is that clear? It's very clever. Is that clear to everybody? It's very, very clear. So you run. Make sure you run once you put. So what is the next thing you do? Class, what's the next thing? You get back to our website. The next thing we'll now to put the linear regression. You understand? And the linear regression is simply saying what? Linear regression is a function. It's already there, written for you. But you're assigning it to the variable name, what? Linreg. Can you see linreg? This is already written for you in Python. This function is already there in Python. You understand? That can calculate regression for you. It's already there. You understand? But you now assign it to a variable linreg. Are we clear on this? So I'm going to pick this, copy, get back here. I'll put it and run. Please, anytime you run and you see error, that means there is a mistake in your spelling. Then you have to rework your spelling. Very, very important. That's just what it means. So I'm going to go back now. I'm going to reshape my X values. So as we are learning, I will be telling you what X values are. You are going to be having features and labels and features. You are going to be understanding what they are. But let's quickly plot this graph. Let's see how we can plot simple graph using Python. So I'm going to put this. So I'm reshaping my X. Then the next thing I will do will be to fit it so that it can now, at any value of X, it will tell me what Y is supposed to be. So once you do that, linear regression dot fit. That's what it does. At every value of x, it's going to tell us what y is. And that is what you actually want. So I'm going to run it. You see, there are no errors. So I'll go back now. Finally, I can now use it to do prediction. Very, very important. That's the whole essence of what we are doing. So that we can predict feature wise. You understand? Given any new S, we should be able to predict a feature Y. So I'll go back. I'll put this. I'll run it. Now that brings us to the matplotlib that we imported. How do you use it? You know, you imported matplotlib as well, PLT, isn't it? And I told you that matplotlib is what you use in plotting graph. So this is how you can plot graph in Python. Simply, we are plotting graph of x, a scattered graph of x against y. So you say plt.scatter xy, then plt.plot x against y predict, and you want to color what you have in red, then you do plt.show in order to show it. So once you click run, boom, you're gonna see what you want. Okay, there's an error. So invalid character identifier. So this red, who can tell me why it's showing error in red? You know, we are copying from our website, and I told you once you copy from our website, make sure you correct your single quote. From the website, it will always give you this error. So once I've corrected it, I'll click on run again. Can you see my graph is plotted? Very simple. Who can tell me why the line of the graph is red? So let me put green. This is what people that learned Excel have been doing for years. You can see it's green now, but you as a programmer, you can design a program like Excel that can do that. Okay, so we've done that. The next thing will be now we need to get the coefficient. Class, are you looking at this? Are you looking at this formula? Who is looking at what I'm doing? Y is equal to what? 2.08x plus 0.13. Abi? So coefficient is what? 2.08. How do you get this coefficient? And how do you get this intercept? That's what we do. So this is the formula or the code to get coefficient. Lingred coef underscore. That's what you use. So to do that, I just simply put it here and run. Can you see my coefficient 2.08? That's why I have 2.08 here. That's how I got this my 2.08 here. So to find the intercept, this is the command for the intercept. So I put it, Control V, I do what? Run. Intercept is what? 0.13. That's why when you get here, when you get here, my intercept is 0.13. Can you see that? So with that, I'm done with this. And with that, I can simply say that the equation governing this is y equal to 0.13 plus 2, or you say y equal to 2.08x plus 0.13. Modeling this equation, y equal to mx plus c. So you see how fast it is? Just few lines of code and we are done. Remember, everything you want is in Christ Jesus. And the easiest way to get to success is by being a born again. Thank you. See you when I see you. Tomorrow, what we are going to be doing is that we are going to be using the skill we've acquired now to predict the prices of homes in United States of America. Just the same thing. This area, what is this area? Who can tell me what is this area with respect to what we've done? That's the x-axis, isn't it? And price, y is the what? Y-axis, isn't it? With it now, we make predictions for pricing new area. Let's say area here stopped at 4,000. Tomorrow, we are going to look at area of 5,000. What will be the price? You see, computer will automatically tell you the answer without doing anything. That is machine learning. You understand? We are using small data now. We've not started using big data. Are you aware? But we want to start from small, isn't it? To big. Thank you. God bless you. See you when I see you tomorrow.